This is going to be section 4.5. We are talking now about the transformation that is called a dilation. Okay, we kept this one separate a little bit because it is the one that's a little bit different. So a dilation is a reduction or enlargement. So we're either going to be shrinking a figure, shrinking a figure, or enlarging a figure. Okay, and it's a reduction or enlargement of a figure with respect to a fixed point called the center of dilation. Okay, and a dilation is an example of a non-rigid transformation. What that means is the shape is going to change size. It's not going to preserve congruency. The previous ones we've done, translations, reflections, and rotations, have all kept the size of the figure the same. The two figures that we have moved around our coordinate plane have been congruent. They've been the same size, same shape. Whereas a dilation is going to have the same shape, but a different size. So therefore, it produces similar figures. Okay, and similar figures have corresponding angles that are congruent, but the corresponding sides are proportional. So let's look over here to the left at our two shapes. We have triangle ABC, which is the small one. That's our pre-image. And triangle A prime, B prime, C prime is our image. So our image has gotten larger, but angle A is congruent to A prime. And angle B is congruent to B prime. And angle C is still congruent to angle C prime. However, our sides are proportional. So while look at side BC. I can tell that side BC has a length of 3, and I can tell that side B prime C prime has a length of 6. So that means that the sides have gotten twice as big. Okay, so that's kind of something to keep in mind. Our sides are twice as big. So that means I don't know what the side AB is, but A prime B prime is 2 times as long as side AB. So that's what proportional means. So let's continue on and look at what is called scale factor. Now, I'm just going to tell you, this is very, very real world because an architect uses this type of thing. Because I'm just going to tell you, an architect or somebody that does plans for a building or a house or any kind of thing they're planning, they usually do it in a small way first. They write them through the plans in a very small way. So they scale the actual size of a house or a building. They scale it down to where you can work with it on graph paper. And so that's why we have a scale factor, because we have to keep everything proportional to what the actual size is so that we can know what we're working with. So the scale factor indicates how much the figure will enlarge or reduce. The variable that we will use for scale factor is K. Okay, so when K is greater than 1, the dilation is an enlargement. It gets bigger. Now, it can't be equal to 1. If K is equal to 1, that means the shape just stays exactly the same. It doesn't get any bigger or any smaller. It's the same exact shape. So K has to be greater than 1 for an enlargement. When K is less than 1, and technically that means K is between 0 and 1, the dilation is a reduction. This shape gets smaller. And the reason we don't use negatives is because if we had a negative scale factor, it would actually then create a reflection as well. So we are not going to deal with that at the moment. So we're just going to deal with those numbers that are between 0 and 1, such as 1/2, 1/4, 1/3, that type of thing. And then greater than 1 might even be 1 1/2. So 3/2. 3/2 would be an example of greater than 1 that you might see in fraction form, and just know that 3/2 means 1.5 or whatever. So that's a number that's bigger than 1, even though it's in fraction form. So if the rule for a dilation, so if our point P is xy, so P is xy, our rule for P prime with a scale factor of k would just be k times x, k times y. It's very, very simple. So we're going to work on that. We're going to do an example on this page first, and then we're going to go ahead and move to another page where I'm going to show you some examples. So remember that my rule is k times x, k times y. So if my points here are r, s, and t, so r is -5, 1, s is -3, 4, and t is 2, -1. Okay, I'm going to use my scale factor is 2. So I'm going to do 2 times every single x value and 2 times every single y value. But before we do that, let me go ahead and graph my original shape. So here's my origin. So -5, 1, 2, 3, 4, 5, 1. Okay, so there is r. And s is -3, 1, 2, 3, 4. So there's s. And t is 2, -1. So I'm going to erase that origin just so it doesn't confuse us. But I'd like to see it. 2, -1. Okay, so there's t. And I'm going to do the best I can drawing lines. I'm not great at that. So there is my original triangle. Now, first of all, is it going to be an enlargement or a reduction? Well, since my k is bigger than 1, my k is greater than 1, remember that would mean it's going to be an enlargement. So my shape, my blue shape, should be larger than my red shape. So let's multiply these out. So -5 times 2 and 1 times 2. So I end up with -10, 2. It's just multiplication. So I'm going to do -3 times 2 and 4 times 2. And I'm going to end up with -6, 8. And I'm going to do 2 times 2 and -1 times 2. And I'm going to get 4, -2. So let's graph those points. So -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. So r prime is right there. S prime would be -6. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. There's S prime. And T prime will be 4, -2. Okay, and I'm going to go ahead and draw that. And notice my triangle, my blue triangle is larger. My angles would be congruent, and my sides, if I could figure out the length of them, they would be proportional. Okay, all right, so there's that. I'm going to actually switch you now to this right here, and we're going to do some practice of just doing some multiplication first. So the first one is another dilation of 2. So I'm going to do times 2 times 2 times 2 times. See what I'm saying? So my f prime, all we're doing is finding the points. That's the first thing I want you to do is find the points. So -1 times 2 is -2. And my y value, -1 times 2, -2. Okay? G prime, -1 times 2 is -2. And 1 times 2 is 2. H prime, this one's an easy one because I gave you lots of 1s. So 1 times 2 and 1 times 2 becomes 2, 2. And I prime times 2 times 2. There's the new points. And we could graph those if we needed to. So looking at this next one, okay, first of all, you know, this was an enlargement because it got bigger. Notice what this scale factor is. The scale factor here is going to create a reduction. Remember, I want you to keep in mind the word scale factor. Scale factor and dilation. So this is going to be, I'm going to multiply each of these by 1/2. Okay, so I'm going to do times 1/2 times 1/2 or 0.5, however you want to do it in your calculator. So S prime is going to be, well, -1 times 1/2 is, I'll do decimals for you. Okay, and then -2 times 1/2 is -1 because half of 2 is 1. And then T prime, well, -1 times 1/2 is -1/2. And 2 times 1/2 is just 1. And then U prime, 1 times 1/2 is 1/2, and -1 times 1/2 is -1/2. So there's our points. Pretty easy, just multiplication. That's the rule. Let's look at some graphs though. So now we're going to graph with another dilation of 2 and another dilation of 1/2, but we're going to actually practice graphing. So what I'm going to need to do is identify my points, Q, R, and S. So Q is at -1, -1. R is at -1, 2. And S is at 2, -2. Okay, I'm going to use my scale factor of 2. So I'm sorry, I need to write Q prime. I'm going to multiply each of those coordinates by 2. So -2, -2. Multiply each of these coordinates by 2. -1 times 2. Remember, my scale factor is 2. So I'm doing 2x, 2y. Just keep that in mind. That's what I'm doing down here. And then 2 times 2 is 4. S prime is 2 times 2 would be 4. -2 times 2 would be -4. So now let's graph those. So -2, -2. There's Q prime. -2, 4. There's R prime. And 4, -4. There's S prime. Okay. And again, let's look at my QR. My side QR is 3. And my side Q prime, R prime should be 6. And that makes sense because it should be twice as big. The sides should be twice as big. All right, let's do this next one. This time we're going to get smaller. So I need to identify E. Let's do D. Sorry, let's do it in order. Alphabetical order. D, E, F. So point D is at 2, 1. Point E is at -2, 3. And point F is at -2, -2. My scale factor this time, my K equals 1/2 or 0.5. So each of these I'm going to do 0.5 times X and 0.5 times Y. So D is going to become D prime, and it will be 1 and then 0.5. And E, E's got 3 is not really divisible by 2, so we're going to say E prime is going to become -1, and then 1/2 of 3 is 1.5. You can put that in the calculator, and it'll give you that decimal. And then F prime is going to be -1, -1. So let's graph this and see what it looks like, because this one should be a reduction. The shape should get smaller. So 1 and then 1/2 That's a really hard one to do, but there's D prime. -1, 1.5. There's E prime. And F would be -1, -1. So there's F prime. And okay, and let's figure out 1, 2, 3, 4, 5. Okay, so the length of EF equals 5. And actually, I should not have a segment above that. If we're going to be technical, when I'm talking about a segment measure, EF equals 5. So now let's find E prime, F prime. Well, if I go from F, I go up 1. Let me do it in a different color so you can see it. I start here at F and I go up 1, 2.5.